Assalamu alaikum. How are you guys? I hope you're doing great. This is the revision class for bioinformatics algorithms. So let's start. So first of all, we have pairwise alignment. So we have here two strings aligned with each other. When we align the same character, this is called match score. Different characters we call it mismatch score, and a character with gap, this is called a gap score. I don't know if this information is important, but uh, the match score is always positive. The mismatch score is could be positive or negative, and the gap score is always negative. So here, let's say this is the original string, okay? When we change a character from the original string to be another character, okay? This is called mutation. When we add a character to the string, this is called insertion. In this case, you can see here's like additional G. And when we delete something from the original string, this is called deletion. Okay, so here we have two types of gaps. Gap opening when we have one gap, and it's not necessarily only when we have one gap. We'll explain it. I will explain it now. Gap extension when we have two gaps back to back. The first one is opening gap and the second is gap extension. So let's say we have this string a gap g, for example. Okay, so this is called the opening and this is called the extension. Okay, so let's say we have only a gap and g. This is called gap opening. Okay, here we have two types for gap score, linear and affine. Here it should be affine. A, this one is A. Uh, Linear, where all the gaps have the same score, the extensions and the openings. Okay. Affine, where the gaps have two types for score, extension and opening. So let's take this example. This is a good example. Here it's affine 2. I've made a mistake. Okay, so let's say we have these two strings and we have to get the alignment score. So here, as you can see, here we have two gaps back to back. In the linear, we said that the extension and the opening, they have the same score. So in this case, it's -3. So we put here -3 and -3. In the affine, we have a score for the intro, and this score is different from the score for the extension. So the intro is -5, this is 5, and the extension is -1. So here, as we can see, the first gap, which is the opening, is -5, and the second gap, which is the extension, is -1. So this is the types of gap score. Um, okay, and here we have the match score and mismatch score. We can see like for match score we put 3, for mismatch score we put -1, then we calculate. So now for global pairwise alignment. So the algorithm is called Needleman-Wunsch, or I don't know how to pronounce this. Okay, so he will give us two strings, in this case x and y, and we have the match score, mismatch score, and the gap. So let's just let's try a table. Try sorry, draw a table. So like this. Oops. Okay. Copy paste this, I guess. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This is good. Um, Another one. Copy it. Paste. 1, 2, 3, 4, 5. Okay, this is good. So let's start. The first one, the X, always put it in the top. So first we will start with the gap. Always we start with the gap in the X and Y, okay? Here we have A, G, this is G, C, T. Okay, then here we have A, C, T, A. Okay, the match score, mismatch score, and gap. So here we have 3, 3, 1 minus 2, 1 minus 2. So first of all, we start. This is always 0. Okay, then this here, here. It depends on the gap score. So let's say here we have minus 2. Okay, so we start this minus 2, then we add another minus 2, which is minus 4, minus 6, minus 8, minus 10. Here the same, the gap score minus 2, we add another one, minus 4, minus 6, minus 8. So let's say we have the gap score is minus 3. So we start minus 3, minus 6, minus 9, and so on, okay? So here, how do we like find this one, for example? Okay, so we have a rule which is here. To find the question mark, in this case, we have here the question mark, okay? We have to find the max of these. So from the above, we sum B with the gap score and the C with the gap score and the diagonal with the alignment of X and Y. I'll explain how. So let's take here this question mark because we're trying to find this. So the first one, let me draw it. A, B, C question mark. Here it should be A plus the alignment of X, Y, B plus gap score, C plus gap score. Okay, so the A here in this example is 0. So put 0 plus the alignment of X and Y. What we mean here by X and Y, here X, here Y. X and Y is the A here, as you can see, like this is the A here, okay? This is the X, this is the Y. So what is the alignment of X and Y? In this case, AA. AA is a match score, as you can see, because it's the same character, right? So since it's a match score, we put here plus 3. This is equal 3. So let's say here it's minus 2, okay? B, which is minus 2, plus the gap score. Gap score is minus 2. We get minus 4. Then we have C. C is minus 2 plus minus 2 is equal minus 4. What is the max of this? The 3, right? We put it here instead of the question mark. You don't have to put question mark for sure. Okay, so it's 3. And where did the 3 come from? From A, right? So I put a diagonal here because it came from the 0, which is A in our case. So here, Again, we have a question mark. Okay. So A is minus 2. What is the alignment of A with A? This is a match score, right? We put plus 3. So what is the score here? 1. Okay. So for B, B is minus 4. Gap score is minus 2. This is minus 6. Okay. The C here is 3, right? So 3 minus the gap score equal 1. So we have this is equal to this, which is the max. So we put, first of all, we put this the highest number or the max number, which is 1 in our case. Okay. And where did it come from? From the A diagonal and from the C. And we continue. We continue solving all the, or filling the table, you can say. And when we finish, we'll get something like this. Okay. So now in um, in the global pairwise alignment, we always mark the most bottom right number. Okay, in our case, it's 4 here, and we have to go to the most top left. So from the most bottom right to the most top left. Why we are doing this? So we can find the alignment. Okay. So how do we do the alignment? Let me erase these. Okay. So here we have a rule. Let's say when it's diagonal, we always put um, the x and the y. When it's like horizontal, let's say, we take the x and we put in the y gap. When it's vertical, we take the y here, the y as you can see, and we let the x be gap. So you will see how, what do I mean? Just give me some minutes, some time. Okay, let's say here, let's start. So it should be, first we start from the right to the left. Okay, so we start from 4 here. Let's take the diagonal. So diagonal, we take both letters, here x and here y, always. Okay, so the x we take, because it's diagonal, we take both letters, in this case t and a for y. Okay, let's say here we take another diagonal here, this one. So it's c with t, c in the x, t in the y. Here another diagonal. Our goal is to reach the most top left. Another diagonal, g with c, g with c. Another diagonal, we take a with a. Okay, here in the global pairwise alignment, these are always connected here. You can draw them, you can like not, but it's better to draw them. Okay, so we are here, right? We were here, so we are now in the minus 2. Minus 2, to reach the 0, we take the horizontal line. So you can say when it's horizontal, it is parallel to the x, right? So we fill the x In this case, it's A. We fill it and we keep the Y empty. So we put gap. So let's take another example. Let me get eraser. Okay. You can like take any lines you want just to reach the top left. But in the end, you have to reach the top left. Okay. So let's take the not the diagonal this time. Let's take the horizontal line. So we start again, x and y. Because we took the horizontal, it is parallel to the x, right? So we write that the x and we keep the y empty. Then diagonal. Diagonal, we take both characters, which is c and a. C for the x here and a for the y. Now we are here on the 5, we take the diagonal. We have g in the x and g in the x and t in the y. Okay. Now we are in the 4. We take the diagonal again, a c, then diagonal again, a. So how can I make sure that what I have done is true? Um, I find the alignment score. So the match score is 3. The mismatch is 1. 1. C with A mismatch, and T with gap is -2 here. The gap score is -2. So we will get 4, right? 4 is equal to 4, the number we got in the most bottom right, then it's true. Here in this case, um, we took like another way to reach the top left. So let's calculate this. This is 1, 1, because mismatch, mismatch. Here also mismatch. Gap, which is -2. Here we got the match score, which is 3. So we got 4, which is equal to the most bottom right number. Then our solution is true. So what is the question for the global alignment? The question is like, do the alignment for or the correct alignment for these two strings, or like he can give us more than one question, like uh, fill the global pairwise table alignment table, sorry, then find the alignment for x and y. So this is for okay, let's take this. We solve this in the lecture. So we will follow the lines, okay? They have drawn the lines. So here it's diagonal. So again, x and y. We start. We have e, e. Always write x and y. E, e. Then it's vertical, right? Vertical is parallel to the y. So we put the y and make or let the x be empty. Then diagonal, which is E and E again. Okay. Diagonal again. We take both letters, H and H. Here it's horizontal, which is parallel to the X. So we take a X, which is G, and we let the Y empty. Diagonal, we take W and W. then diagonal A and A, horizontal, which is parallel to the X. We take G, we make Y as empty, or let it empty. Um, Here it's horizontal again, parallel to the X. I take A for the X's and keep Y empty. Diagonal, we take E and P, E and P. Then horizontal. Horizontal, it's parallel to the X's. Then we take H and keep Y gap. Let's see, AG gap, AAWWGH, HEE. Yes, it's right. And that's it for global pairwise alignment. Okay, so let's go for the next page. Okay, so here we have some rules for the global pairwise alignment. So first of all, negative numbers are allowed. We'll see why I've put this here, because in the local pairwise alignment, the negative numbers are not allowed. So the second rule, we start from the most bottom right number. We always mark it, as I've said. We backtrack till we reach the most top left. We backtrack till we reach the most top left. Okay. So let's go for the local pairwise alignment. So what is the difference between local pairwise alignment and global pairwise alignment? Let's see the rules here. Negative numbers are not allowed. So in the global, as we saw, the negative numbers are allowed. Okay, but in the local, it's not allowed. What we do if we get a negative number, we put 0 instead of it, okay, and we don't put backtrack for it. So let's say we find, like, let's say 3, 5, and we have to find this, and the answer was the maximum number between all of these was a negative number, let's say -1. So we put 0 and we don't put backtrack for any of these numbers, okay? Um, okay, we start from the largest number. This is the second difference, which is we start from the largest number of, in the table, then we go to the top left, or to the most top left. So let's take this example. Okay, I'll draw the table. Sorry. Oops. Okay. Okay. This is enough. Okay. So let's start. We always start with the gaps, then G, A, T, T, G, A, then A, C, G, C. So the match score is 4, the mismatch is -1 and the gap is -2. The gap. So if you remember, in the global we put here 0, then we start with the gap score, put it -2, -4, but here it's not the same because this is local. We said the zeros are not allowed. Sorry, the negative numbers are not allowed. So put zeros instead. And one more thing, if you remember, I've said in the global alignment, these are connected. These, but in the local, they are not connected. Okay, this is third difference. So let's draw. Always draw it, so you can know the value of this question mark or this like gap, or I don't know, the empty square. It's better. Okay, question mark. We have here x, y. So the question mark is equal to the max between a plus the alignment of x and y, or b plus the gap score, or c plus the gap score. Okay, so let's start. Um, Here we have 0, the a is 0, plus the alignment of g and a, it's -1, which is equal to -1. Okay, the second, it's 0 plus -2, because the b is 0 and the gap, it's -2. Uh, Here we have the c is 0 plus -2. Okay, the maximum is -1, but it's negative number, so we don't put negative numbers. We put 0 instead, and we don't put backtrack. Okay, so let's do this. This is 0. This is not 0. Okay, this is 0. Um, Here we have a match score with the diagonal. We have match score plus 0, so 4 plus 0, and the horizontal, or from B and C, we'll get -2, -2. Here we will get, we have mismatch, so it's 0, -1 from the diagonal. Uh, B is 0 plus -2, it's -2. Here we have C -2 because it's C plus gap, gap is -2, so we get here 2, and we put backtrack. Again, here it will be, because it's T and A from the diagonal, so it's -1, so it's 0, 0 from from C. Here it will be mismatch, gap, gap, which is 0. Here we have match from the diagonal, so it's 4, 0 plus 4, because it's match. I hope like you understood the concept, because I'm trying to do it fast. So okay, let's take this slow. Here from the diagonal, it's 0 plus mismatch, which is -1. Okay. From B plus gap score, which is -2. Here's C plus gap score, which is 0 plus -2, which is -2. So you will get 0. Here, the diagonal, this is C by the way. Okay, and this is C. From the diagonal here, we will get mismatch, which is -1 plus the A. The A is 0, so it's -1. Here we have B plus gap, which is 4 -2, and we have C plus gap, which is 0 minus 2. So the maximum is 2, and it came from the 4. Uh, let's take last one. Here we say uh, it's a mismatch. So it is 4 minus 1, because we have here A minus 1, which is mismatch between A and C. Okay. Sorry. From the B, we have 2 minus 2, because it's 2 minus gap. And from C, it's 2 minus 2 again. So these are zeros, and this is 3, so it came from diagonal. Okay, so we continue. Here I missed this, by the way, and the paper absent. So we will get this table. What is the maximum number or the largest number in the table? It's 5. I start from 5 and backtrack till the top left. Okay, so again, let's find the alignment. Let's go, guys. So diagonal, right? Sorry, we start with the diagonal because it's the only option here to go to the top left. Diagonal, I take G from the x's, always x and y. This the top is x and the left is y. So GG, then let's take the horizontal. Horizontal is parallel to the x, so I take x and keep y empty. Let's take diagonal because it's the only option here. Diagonal, I take two letters, both of them. So it's T for the X and C for the Y. Okay. Here in the AA, sorry, not in the A, in the 4, I take the diagonal. It's AA. Okay. So here, if it was a global alignment, I would take this because it's connected. But because it's local, local are not connected. Okay. Even these are not connected here, only in the global. So how can I make sure this is like what I've done is correct or not? I calculate the alignment score. GG is a match, which is 4. T with gap minus 2. T with C mismatch, and A with A is 4. So I get here 5, which is 5 in the table, the maximum number and the number I've started with. So it's right. Okay. So that's it for local alignment. Where's the laser? Oh, okay. No, this was here. Yes, I've missed it in the paper. Okay. So he gave us this thing. I don't know what is he going to ask us about it. So let's say he gave us this table. Okay, I don't have to do it actually. Let's say he gave us this table and put E here and A and said what is the alignment of A E. Okay, so we don't have the alignment of A E, but based on the rules we have made here, as you remember, A plus SXY, or the alignment of X and Y. So here, what is the alignment of SAE? We can say it's A, let's say this is the question mark, as if you can remember. A is equal to the alignment of S, A with E, okay, equal to number. This number was the question mark, but surprisingly, we have the question mark here. So the question mark is minus 4. The A is minus 6. So we can calculate it. So this will be what? 2, right? Yes, it's 2. So let's take this again. Let's say he said, what is the alignment of AE? Okay. So as you can remember, this is A, this is question mark. So A plus the alignment of AE equal question mark. But we have the question mark and we have the A. The A is minus 2, sorry, minus 2 plus the alignment of AE. The question mark is minus 3. So what is the solution here, or what is the alignment? It's minus 1. Minus 2 plus minus 1 is minus 3. Okay, we are done with what? With local pairwise alignment. Let's delete these. He gave us some examples, so I'll try to solve them. Okay, so we have finished here. We take the rules. Yes, so let's go for the examples. So here, I don't know. Let's see. In the week 2, okay, in the slides, page, what page? I don't know, I forgot. Let's see. In the slide, okay, in the slide 47, we have this example. So here the maximum number is 14, right? So we start from 14. I don't know if I can, no, I can't. Okay, so here it's diagonal, right? So I put and F and F. F for the X and F for the Y. Okay? Then it's diagonal again. E and E. E and E for X and Y. Diagonal. I take diagonal here between the 2 and 6. I take the L and L. Okay? L and L for the X and Y. So here, from the 2 to 3, it's horizontal. Sorry, it's vertical. And it's parallel to the Y. So I take the Y, the value of the Y, which is V, I put it in the Y, and put X, sorry, gap in the X. Here, it's it is horizontal, so it's parallel to the X's. So I take the value of the x, which is a, okay, I put it, and in the y, I put gap, gap, sorry. So here it's diagonal between the 4 and 0, so I take both letters, so it's kk. And we have this example too, you can try to solve it, guys. And this one, yes, that's it. So let's go back for the multiple sequence alignment. So this is a nice question, I guess. So the question is, find the string that is most similar to the other sk. This is sk, by the way. Sk. Align all strings. I missed the s. Align all strings with respect to sk. So to find the string that is most similar to the other, which is sk, it's called sk. I do the similarity matrix. So what is the similarity matrix? We put all the strings one, two, three, one, two, three. This is 2, this is 3, this is 4. Okay, so here if you can see, this is these are given here, these ones are given. Okay, so what is the alignment score for 1 and 2? So first of all, we don't have alignment between the same strings. Okay, so between 1 and 1, 2, 2, 3, 3, they are all the zeros. Okay, so what is the alignment between string 1 and string 2? It's 0. And here, if you can see, it's also 1 and 2, so it's 0, 2. What is the alignment between S1 and S3? S1 is and S3, it's 3. Okay, here it's the same. What is the alignment between S1 and S4? S1 and S4 is 14. As you can see here, it's 14. This is the alignment score. Okay. So what is the alignment score between A and between S2 and S3? S2 and S3, here it's -1. -1, -1. What is the alignment score between S2 and S4? S2 and S4, it's 4. Okay, so we put 4. Um, what is the alignment score between S3 and S4? S3 and S4, it's 4. Again, it's the same. So here, as you can see, the sum of this row, it's 0 plus 0 plus 3 plus 14, so it's 17. The sum of this row is 3. 0, 0 minus 1, 4, so it's 3. Here the sum is 6. Here the sum is 8 plus 14, which is 22. So the maximum number, when we get the maximum number, the string of it is the most similar to the other strings. Okay, find the string that is the most similar to the others. Okay, we found it, which is S4 in this case. So align all strings with respect to sk. So I have to write these. Let me take text, it will be easier. S1 equal A T C T T A G. The S2 A gap 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 T gap G. Is it right? It's not. A3 gaps T. No, it is. Okay, so let's take another one. So, S2 A is equal to ATT AG. S4 is equal to A gap T gap G. Okay, so the third one is S3 equal AG C TG, and the S4 is equal to A gap gap TG. This should be 4, by the way. Okay, so what we have done here, we are trying to align to align all the strings with respect to sk. So what is the most similar string we have found? It is S4. So we find S4 aligned with other or with all the other strings. Okay, so we find the one S4 and S1 and S2, S4 here, then S3 and S4. So we find the, let's say, the strings that are aligned to the most similar string, which is S4. So we find it, we will try to write all of them on one side, okay? So S4 with S1, S4 with S2, S4 and with S3. Then, sorry, we'll start with the S4. Always, we start with the S4. So here we see A, A. It's okay. Gap, gap, gap. It's okay. Here we have gap, but here we have T, here we have gap. So I have to add gap here. Let's delete this. Okay, so it's not confusing. I have to add gap here and also gap here. The third, because I've added it after like two characters, let's say. So here I have to add it after two characters again. So let's do it again. A gap gap. A gap gap. The gap I've added. Okay. So it should be, let me write it again. It would be easier. A gap gap. And here a gap gap. So it's okay. Then let's go again. A gap gap gap. A gap gap. Okay, so I have to add one gap here, and here we have a gap gap. Also, I have to add one gap here. Okay, so it would be two here. So I have now a t t a t gap gap t a g, and here I have a gap gap gap, the one I have added because it's missing. Then t gap g. This for this. Okay. Here, for this, I have AGCT gap, sorry, can't go back for some reason. So here I have AGC gap, I have added TG, okay? And here I have a gap, gap, TG. So let's go again with the strings, the S4. Here I have a gap, gap. So a three gaps. Here I have a gap, gap. A gap. Okay, it's okay. Then I have T, or let's say T, because this is the new one. These are the new ones for these. Okay, it's okay. After the T, I have gap here. I have gap here, but here I don't have gap. So I have to add gap here and gap to the S3. Okay, so let's go again. A3 gaps. A3 gaps here. A3 gaps. I have T. I have gap. The last one is G. So these are the new strings, which is the S2, this one, the S3, sorry, oh, I can't go back, why? Let me put, okay, fine. Uh, Here, this is the new S3. I have the S1, it's the same. And here I have the S4. You got it, guys? So S1, S2, S3, S4. I will rewrite them and say these are the alignment. So let's compare AT, ATC, TTAG. For S2, I have AT, two gaps, TAG. Okay? For S3, I don't know if it's visible for you. AG, AGC. Here I have AGC, gap T gap, gap T gap, then G. Okay? Then I have the S4, which is I can take it from this one. Okay? So that's it for the multiple sequence alignment. I hope it's clear. I've tried my best, but it is what it is. Delete this. Okay. So let's go for the suffix trees. Suffix trees is easy, don't worry. It's easier than the multiple sequence alignment. So suffix trees, yes, we have to start. Okay, the edges in suffix trees, not all the edges by the way, the only ones that are starting from the root. Shouldn't start with this, start with the same first character or letter. And each internal node should have two, or let's say at least two edges going out of it. Okay, so here, as we can see, this this edge is starting with the letter C, this one with the letter B, this one with the letter A, this one with the letter D. Okay, they are not like A, this one is A, this one is A. No, they are not the same. Okay, now I can't undo. Okay, I don't know what's happening. Okay, let's go. Here in the internal node, this one, I have two edges going out of it, at least. It could be three, it could be four, it's normal, okay? So, um, he will give us the string A, B, so A, B, C, A, D. He will tell us write or draw the suffix tree, sorry. So let's start. It's no, we start first of all. We will write the suffixes. So the number of suffixes is depending on the number of the characters. So here we have 5 characters, so it's 5 suffix. Let me write it like this. The first one will be the same for the string, which is A, B, C, A, D. The second one will be B, C, A, D. So what we have done, we have deleted the first letter. Okay, here we will repeat the same thing. We will delete the first letter. C, A, D. Here, A, D. Here, D. Okay, so now we will start drawing. This is S1, A, B, C, A, D. This one is starting with B, so we can draw this S2, B, C, A, D. Here we have CAD, so this is S3, CAD. Here we have AD, but we shouldn't like draw another A, as we can as we have said, we shouldn't draw more than one edge starting with the same letter. Okay, so what we will do here, as you can see, here we have A, right? So we will put a node here and put an edge. This is the S4, so it will be A. We have here A, as you can see, then D. So it will be A, D. This is the S4. S5, it's D. So we'll put it like this. You might say like, but this started with D and this started with D. Okay, but the edges from the root shouldn't start with the same letter. Okay, not the internal nodes. So we have draw it. Okay, here we have we he might ask us question, which is P in S or like it's the same question, or is it a substring? So he might ask us is B or P, let's say P is in S, or P is a substring. So how can I know from the suffixes I've wrote, sorry, um, I can find that BC, let's say this is BC, okay, is not any of the prefix, or sorry, it is, because BC, it is here, right? It is one of the prefix of the suffixes. But BD, let's say BD is not a prefix for any suffix. So it is not in um, it is not in S. Here, as you can see the note, if P is in S, then P is a prefix of one of the suffixes of S. So it should be, or it must be, a prefix of one of the suffixes. Other than that, if it's not there, it's not a prefix, then it's not in S. Okay? Here it's, I think this is very important, this one. So let's take, um, let's solve this out, at first. Um, okay, okay. So here we have S equal um, ACC dollar sign. Is the dollar sign? Okay, okay. So we'll start. Um, sorry, we'll start with the suffix the suffixes. So we start with one. Oh, this is so annoying. So the first one is the same. It's always the same. Okay. Okay. Second one will be the same, but we delete the first letter. Third will be the same, but we delete the first letter. And we continue. I always delete the first letter, okay, guys? Let me delete as fast as I can. So 7, 8, and 9. This is okay. This is not. This is not dollar sign, right? 4, 5, 6, 7, 8, 9. Okay. Sorry. So let's start first of all with the first suffix. This is what S1. So here we have A, C, C, A, C, G, C, G, dollar sign. Okay. Then we have C. It is what? Different letter. So I can start with another edge. C, C, A, C, G, C, G, dollar sign. Here I have CA, but here I have C2. I shouldn't start with another edge, so I write node here. I have here S3, so I have C, then A, C, G, C, G dollar sign. Okay, then I have AC. Here, as you can see, I have AC here, so I put a node here. Then this is S4. I have AC, AC, as you can see, then GCG dollar sign. Okay, here I have CG. I have here C. Here I don't have G, so I put another node. So I have C, G, C, G dollar sign. This is what? S5. Okay. I hope it's clear my writing because it's very hard to write here. Here I have G, so we start another node, which is S6. I have G, C, G dollar sign. Okay. Here I have CG. Here I have C, as you can see. I have G here, so I put a node here because it's CG, then dollar sign S7. CG dollar sign. I have GC now. Here I have G node. Oh, sorry, GS or dollar sign. I'm calling the dollar sign S. Uh, Here I have S8 dollar sign because as you can see, I have G here. G. If put node, then I I will complete it to the dollar sign. Then I have dollar sign. This is S9 dollar sign. Okay. So as you can see, like each edge that is going out from the node or the root node, okay, it is what starting with a different letter. So here C or sorry, here A, here C, here G, here dollar sign. Okay. So here we have two important questions. The most repeated character in C. Sorry. I've read the solution. What is the most repeated character? Like you can see here, it's okay. You can say it's 4, but if he said Y, you can say because we found 4 C's here. Okay. So what is this the right solution? Here, as you can see, C has 4 leaves. So what is the leaf? Let me write something. Okay. Okay. So this is the root. Okay. These, the last ones, are the leaves. and everything between the root and the leaves are internal nodes. Okay, so here C has four leaves. One, two, three, four, which is the most. So that's why the most repeated character is C. Okay. Then, what is the longest string that repeats? Let's explain it here. As you can see here, C it has four leaves. It's much better, right? Okay. So, what is the longest string that repeats itself? How can I know it? Uh, they have the longest string before the node or before the internal node, let's say. First of all, this should be here. The node should be here. Okay, up one, like one character. I've done it by mistake. Um, so what is the longest string before the internal nodes? Here, as you can see, we have two characters. Here we have one. Here we have one. Here there's no internal node. Here in this leaf or in this like edge, as you can see, we have before this internal node, we have G and C. So, what is the most like, or the largest, or the longest, let's say, the longest string before the internal node? AC, we found it here, and GC. These are the solutions. Here for this node, let's take this example. Okay, so what is the suffix tree for this? Well, I'm starting again with drawing. We should always like start with the suffix trees or the suffixes, not the suffix trees. Here A, I delete the first character A, B, A. Here B, A, and here A. Okay, so first of all, we have here the S1. I have A, B, A, A. Here for this, I can do it like this: A, B, A, or sorry, B, A. Then BA S3, I have here B and A. Here to represent A, I can't put a new edge because there will be like two edges starting with the same character, with the same first character, let's say, which is wrong. So I should put the A here, but it's wrong. This is wrong. We can't put it like this. Okay, guys? So how can I make this suffix tree? No, not suffix tree, because it's not suffix tree, because I couldn't represent it as a suffix tree, right? So how can I make it a suffix tree? I add a special character to the end of the string, okay? So here, if we do it again, what we will get? I have A, B, A dollar sign. This is the S1. I have AB here, control B, A dollar sign. This is the S2. Here I have S3, which is BA dollar sign. Here I have AS. Here, as I can see, I can put here S4, S, or sorry, dollar sign. And here I can end it with the dollar sign. S5 dollar sign. Okay, guys? So now it is a suffix tree. How did I solve the problem? I just added a special character, which is always dollar sign, to the end of the suffix tree, or to the end of the string. Sorry. Okay. So that's it. Here, this table, you should memorize it. This one. Okay. Here for the suffix array, um, it is easy, but I don't know like how what question we can have for the suffix array. So I will take an easier example, okay, guys, because this will take a long time here. Let's say we have S equal to A, B, C, B. Let's say. Calculate CB. Let's take, let's say AAGCT. AAGCT. Okay. So what we are going to do first for the suffix array, we will write the suffixes too. Okay. So S1. Um, so bro, what is happening? Okay, so let's write it. Never mind. AAGCT. S2 equal to AG. We always delete the first letter. GCT. S4 is equal to CT. Then we have T only. So what we are going to do is number them based on the alphabetic order, okay? So the first one will be AA because it's obvious. It is A then A. So this one will be the first one. The second A we have is A, or sorry, S2. Then we have C. Then we have A, B, C, D, G, then T. Okay? So now what are we going to do? We will put the number 0, 1, 2, 3, 4. So here we have 5 and here we have 5, right? But we will start with the 0. Then the first one, as you can see, this is like you can say this is the same of this, and this is the same for this. 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 It is the same, but we will start from 0, okay? So here we have 1, which, what is the number of the suffix? It's 1, 2, right? Here we have 1, 2, or in the 1, so it's confusing. In the 1, what is the number of the suffix? It's 2. So it's 1, 2. Then we have in the 2, the number of the suffix, as we can see here, this is 4. So I put 4. Then this is the suffix. The number of the suffix is 3. Then the number of the suffix is 5. So it's 1, 2, 4, 3, 5. Okay? So what we are doing, the number I see it represents what suffix? The number what suffix? The number, what suffix here? I put it here, 4, in the third place. Here I have the number 3, which is it represents the suffix 4, or sorry, 3. I put it as 3, okay? And here 5, because it is 5. The fifth place represents the suffix 5. So I can write the suffixes. So the first suffix is a g c t. The second one a g c t. The 4 is not this. 4 is c t. As you can see, the suffix is the suffix number 4, it's c t. The suffix number 3, g c t. The suffix number 5, it's t. Sorry, right? So let's say he said, how can I find p equal, say, um, let's say, yes, ag. Okay, so let me erase this. This is our table. So what is the number that is in the middle? It's 2, right? Because we have 2 here, 2 here, so it is 2. I will go to the second, or the number that is in the middle. Takes the suffix of it. Okay? What is the suffix of number 2? It's 4. 4, it's CT. I've written it here already, right? Here, CT. So, is AG bigger than, or let's say not bigger, should AG in the alphabetic order, okay? Should it be before or after C? Here we can see this one is starting with A, and this one is starting with C, right? So this should be before the CT. So I ignore everything from CT and after CT, everything that is after CT. Then I do the same here. I will try to find the number that is between 0 and 1. There's no number, so I choose either like 1 or 0, which I think we will choose 1 here. Okay? Then we will see, is AG in the suffix 2, which is AGCT. We wrote it here already. Okay? Is AG there? Yes, it is. So I found the P I am looking for. Okay, so this is called, as he said, the professor, it's called the binary search. It is known, actually, binary search is known. And that is how the binary search works. It goes for the middle number, then it compares the number to it. If the number is less, we will look for everything that is before that number, in our case 0 and 1. If it is bigger, like the p, let's say the b is, for example, um, I could see, say et, for example, anything. Okay, et is bigger than ct, right? Because e is after c. So we will ignore everything from C and before C, and we will go to everything that is after CT, okay? We will take the middle number again, do the same exact um, procedure, okay? And we will continue repeating it till we find our ET. If we didn't find it, then it's not in the string or not in the suffixes, okay? So I think like when he was talking about the final, he said he will ask about searching strategies. Like I don't know how can he ask that question using the suffix array, but I think that's how is he's going to do it. So here you can see the example, guys. It's very easy. Like I've ordered all the suffixes with the alphabetic order. Okay, then I've put the number here. The number for like this one is one or zero. The second is two. Okay, like this. I've put the numbers here. Then I see like for example, zero is for one, right? But what is the number of the suffix? It's three. So I put three here. Again, for one, this is two, right? It is two. What is the number of the suffix? It's four. For two, what is it represents three here. What is the number of the suffix one? I put everything, then put the characters. Actually, like he said, the professor said, uh, we won't care about these ones. Like don't care about these ones because we can use only these. We can start from the middle, which is 9. Okay, I can start. Okay, 9, it's the suffix 9, right? So I go to the suffix 9, 80, dollar sign. I compare it. If it is after, it should be the character I'm looking for. In our example, it was AA, P equal AA, okay? So it should be before 80 dollar sign. So we ignore everything after the 9 and we do the exact same procedure here. We will look for the middle number, the number that is in the middle, okay? Uh, we will find, sorry, we will compare it to the number in the middle. If it should be less or bigger, we will decide where we are going, up or down, okay? Here you can read this. I don't know if it's clear or not. Here we have, yes, this, I'm sorry, I think it's, the video is very long. Yes, 1 hour to 32, not 32, 23 minutes. I'm sorry, but like I'm trying my best, and I hope you understood the subject. It's easy, but you have just to understand because we don't have like too many topics, right? We just have to understand these topics and go to the exam. So here, in this question, he might give us a table, okay? In our case, this one, and ask us for the alignment score. So he will give us here, as you can see, the opening, as you can remember. Like the first gap is called the opening, and the rest is called the extension. But this is only in case we have more than one gap. Let's say we have gap A gap. So this is opening and this is opening. We don't call this as extension. The extension is only after the opening of the gap, back to back. Okay? This is extension. This is opening. Sorry. So we have the gap and the extension is equal to -1 and here is -8. Sorry. We can call the gap extension, by the way, widening. Okay, guys, be careful. So here we are aligning A with A, right? So we go to the table to the table where we find it's AA, so the alignment is 4. So the score is 4 for the AA. Then A with gap, we have the gap, it's -8, right? Let me write it. Why am I writing it here? So it is -4 and -8. Then we have CC. We go to the table, we find C with C, which is 9 here. Okay? Then we have D with D. We have D here with D here, which is 6. Then we have Q with gap. Gap, it's -8. RR, we have R here and R here, it is 5. We have SS, it is SS, it is 4. And the last one, T with T. T with T, it's 5. Then we sum all of these, we'll get the alignment score. So he gave us like another example here to solve. You can like solve it, guys. You can pause the video here and solve it. It is solved already, but you can see it. He got everything from the table, by the way. Here he was giving like example for how to write the alignments from the table of the local or global pairwise alignment. Here we have, yes, here we have the same example actually. I've put in the what in the paper. We solved it. Here we have the one that was like asking what is the most repeated character, what is the longest what was it called, like the the longest string that repeats itself. Okay, I've explained it. um, this one are the complexity, and this one, yes, this is the multiple sequence alignment. So for this, I don't know if this is important, by the way, how many A's he's asking. So we find here A, then A, then A, so it's 3. I don't know if this is important or not. For the complexity, he said like we just have to memorize. Like let's say he said what is the time complexity for suffix 3. You say big O, not big O of n square for space for search. By the way, I've put everything. I've already put everything in the table here. You can find it. Sorry, you can find it here in the table. So, what is the time complexity for suffix 3? What is the space complexity, search complexity? We can put this or this. By the way, I prefer this because he was like repeating it too much. But if he asked about this, it's also possible. Sorry. For suffix array, we have n log n, we have on, and we have o log n. For the local and the global alignment, so here for the local, he gave us its x multiplied by y and x multiplied by y. For the global, by the way, global alignment, I don't know if it's the same because he didn't like give us the complexity in the lectures. He didn't talk about it. But when I've searched about the global alignment on the internet, I found it is M, or let's say, sorry, go back. I found it was M multiplied by N, which is the same for X and Y, by the way. So I've put here local slash global alignment. So this is the subject. I'm sorry that it took me like, yes, 1.5 hours. But this should be enough for the subject, I guess. Um, I don't think the lectures are important because he covered everything actually. Um, yes, and that's it. Thank you so much, guys, for listening. Um, I hope you have a good exam and get very good grades. Make dua for me and see you later, guys. Good luck.